Am I audible to you? Okay, that's great. Um, Now, today we will continue our discussion on histogram matching. So, histogram equalization we completed, right? In that, what was the conclusion? That if we uh, want to equalize the histogram, that means we want that all the intensities are occurring in almost similar way, similar manner, or in the similar count. Then we have a procedure. What is that procedure? That we have to take probability of occurrence of each intensity. Then we have to, for if I am suppose I am finding for equivalent intensity for 0, that means I will take probability of occurrence of 0, summation of probability of occurrence of 0 to 0, like k is 0, because I want to find out s of 0, and L minus 1. Suppose I want to find out S of 1, what it indicates? If in input 1 is my intensity, then what it should be replaced with, so that it will be the summation of probability from 0 to 1, multiplicate probability and summation of that multiplied with L minus 1. In that way I will obtain all these values, right? And we have to round it off, because I know 1.33 cannot be possible intensity value. So whenever 0 occurs, I should replace it with 1. Rounding off takes place. According to that, I can get a new histogram. So that we have already discussed. Now, what we it is remaining, like if this is the input image, right? Then what I will do, if input image is given to me, then I am going to find out its histogram. I know that the histogram of this is concentrated over right hand left hand side, because it is a dark image. Then from this histogram I am going to get of the probability of occurrence. Then from probability of occurrence and that equation of L minus 1 and summation 1, that, and using this probability values here, I am going to get S values. Then I will, from this S values, I will note that what should be the input value, so that I should replace it with that output value. If 0 occurs, it should replace with 1, whatever. If 1 occurs, it should replace with 3, kind of thing we obtain. So in that way I am going to replace all these values here, so I will obtain this. And you will see it is enhanced contrast image. Okay. And what I did, I take particular value, I saw this in this list, and I obtained that, okay, for this particular value of R, what should be the new value of S? In that way I replaced it, and I obtained this enhanced image. And then I obtained histogram of this image. That is, you can see, instead of concentrated over certain location, it is spreaded on all the locations, right? Same thing was done for this, all right? So also here you will see that enhanced images. So I obtained enhanced image, okay. And it is also, it was washed out. This is enhanced contrast, this was low contrast, it is enhanced contrast. It was already having good contrast, and after applying histogram equalization, it is still a good contrast image. Okay, so now if you will observe that whatever the histogram of your input is, whether it is concentrated over left hand side, whether it is concentrated over right hand side, right, or whether it is concentrated over some center location, right, still if you will apply histogram equalization, it is going to be of a broader region. After applying histogram equalization, all the images are looking same, whether it was this image or this image, they are now almost same image, or rather we can say they are approximately almost, I mean we can say majority they are almost equal. If you will see, these two are almost equal, slight difference is there, but of course you can approximately say that all these images are almost equal, right? So interesting conclusion we have obtained. Whatever the histogram of the input is, if I apply apply the transformation of histogram equalization, whatever image I obtain, right? And I have another image, say R1. This how R and R1 are different. Suppose this is R and this is R1. These two are images are same, just the distribution of intensities are different, right? So, if the histogram is concentrated on the right hand side, or histogram is concentrated on the left hand side, or it is concentrated over center, R1 can be this even, R1 can be this even. This can be any R1, right? If I am considering this as R. So, if I am applying histogram equalization to this, and if I am applying histogram equalization to uh, other distribution of images, same still, just intensity distribution is different. And if I am applying histogram equalization on both the images, the resultant images here, say S, or and this is S1. S and S1 are equal. S and S1 are equal, right? So very important result it is, right? So this we are going to use in the next concept, right? Now here, if you will see, uh, okay, this is how the transformation was applied. Like if this is for the image one, like this is input image, this is output image, and this shape of applied, this type of transformation applied to obtain this image, right? And if you want to verify here, this is input image and output image are almost same. That means in which transformation we are having input and output images same, almost equal. So which transformation is that? When input and output images are same, they are not changed. Which transformation does not change input image? Is it negative or identity? Is it negative or identity? Yes, it is identity transformation. In that identity transformation, the shape of the transformation was a straight line, right? If you remember, and that you can see that in fourth transformation is almost a straight line. You can see it is a almost straight line, right? Because the input and output images are almost equal. That is what you can see here. That is a line at 45-degree slope that you can see here. Okay, so that is what, but important conclusion we have derived here. Now, next is histogram matching. What is histogram matching? Histogram matching is that suppose this, I don't want to, I don't want to, what you can say, equalize the histogram. That means if this image is given, if this image is given, I don't want to get enhanced contrast, but instead I want to get this type of image. I want a washed out appearance. I want a low contrast. If suppose low contrast is given, I want a bright contrast, right? So I want a particular type of histogram. I don't want to have a just high contrast stretched out image, but I want a particular type of histogram. Where does that help? So I can show you that example. Suppose I am having this image. I want to see. I am interested in the information in this region. So I know that if I want to see the image in this area, first of all that thing comes in my mind, because only few intensities are there in the image. I may apply histogram equalization, right? Of course, you can go with histogram, any other operation of the histogram. It can be that gamma transformation, log transformation, right? But which one will you choose? That is again trial and error, right? But suppose you are opting histogram equalization, right? So will that histogram equalization help? This is what the histogram equalization result is. Of course, somewhat information is visible here which was not visible clearly here, but still entire image result is washed out. The result is quite bright, that I don't require. I don't want this type of and degradation in my histogram, degradation in my image. Here also it is degraded. You can see this is a dark gray color now. So what we can do is that then what is requirement, that if it is if it is matched with, or if histogram of this image is enhanced in this way, What was the earlier histogram? The earlier histogram of this image was like this. This was the shape, right? And as expected, more intensities were on the um, what we can say on the left hand side. What histogram equalization did, that all the intensities are almost equal. So what happened, that dark intensities become bright, this intensities become bright, and that is how this gray color and every, I mean all the histograms are, all entire histogram shape is should be equal kind of thing happened here, right? So that's why what happened, that this become bright, this become bright, okay, this become bright, but this also became bright. I did not want that. I want this should remain as it is, this should remain as it is, this should get altered. That means I want that, okay, if it is my dark portion, some dark, it is very dark, then it should remain dark, but if it is somewhere here, then I want this type of distribution. So can I say I don't want equalized histogram, but I want a specific shape of histogram. Here it should remain as it is, or rather it should have high values here because I want overall dark appearance of my image, right? And some of the dark values should get brighter ones. So this is what intuitively I want this type of spread. Okay. So what? So here, what is my requirement? Requirement is that I want that my histogram of my original image should get altered as I specify. My histogram of my image should be matched with the one that I specify, right? So that is what the requirement is here. So what we did, this type of histogram was chosen, so that original image histogram, this histogram was matched with this one by some transformation. This is that transformation. This type of transformation was applied. Earlier, this is for the equalization, but equalization did not work. So we applied this type of transformation and we obtained this type of shape. You can see, as expected, we obtained that type of shape. And result of that type of matching, result of this type of histogram is like this. And you can see here, this information is visible here, this information is visible, and overall look, of course, this has become brighter, but it is not as bad as it was in the equalization part. So this is much better, much enhanced image. If you will see in this region, that is quite visible. In this region, these are in this information is quite visible. Okay, so what was our requirement, that our histogram should get matched with the one that we specify, and that operation is known as histogram matching or histogram specification. What we do, that we transform our image such a way that it histogram of the transformed image will match with the histogram that we specify. Okay, so what is the procedure for that? How will we do that? So procedure for that includes certain steps. First step is, take your input image is R image. Okay, so equalize that image using the previous method that you used. So now suppose this image is given to you, that is your R, and you will equalize. So you are going to get this image, right? Suppose this is your image Z. What is Z? That is a specified one. That means you want that histogram of this image, which is concentrated on the left hand side, should have histogram now which is concentrated on the right hand side, right? Not necessarily histogram, this image, specified image should be same as your input. It can be of it can be any image here, but here just for understanding purpose I am taking the same one, but Z can be any image of your choice. It can be any histogram that you specify, right? So not necessarily that should be the same. Here it can be your photograph having particular distribution even, that is okay, that's all right. So that is what I want, that Z is my image, that I want our histogram should look like a histogram of Z, right? So first step is equalize R. Second step is equalize Z. How to equalize Z? So obtain, this is also equalization. Both are equalization only, right? So the function we are using to equalize, of course, the same transformation is not applied here. Whatever we have applied to R will be different from Z. So they have taken just G function, but otherwise, procedure wise, they are exactly same procedures. So what is this? This is actually your equalized version of R is known as S, and equalized version of Z is known as S1. And I know that once I obtain equalized images, they are almost the same, right? So equate them. So you equate them. So third step is equate S and S1 because they are same images. So now I have TR is equal to GZ. Now what is my requirement? What is my requirement? I want to obtain this kind of image. I want to obtain this kind of image. What I have is R. So what I want to actually obtain, that what should I do to R, which function I should apply to R, certain functions I'm going to apply to R so that I can get Z. So what is how Z is obtained from R? What should be the modification that I should apply here so that I can get this? Right. So if I want to if I want to get like Z should be some function of R, what should be the equation? How can I obtain Z from this equation? So it is very simpler way that I am going to get G inverse of T of R, right? So I will obtain this G inverse of T of R, and this is what it indicates, like you take your input intensity R and apply this to function so that you will get Z. What is Z? Z is desired image having desired histogram. These are very basic steps of histogram matching. Okay, so let us start with the examples. It will be even more clearer, right? So, okay, so now first of all, this is the same procedure that we have discussed. Now, example is this. Your input. Let us start with the continuous one. So, how to obtain T of R if R is a continuous one? How we were getting T of R if it is a continuous one? So how we were obtaining T of R if it is a continuous one? So we were taking L minus 1 integration of PR 0 to R, and the W variable of the integral was W. The same logic if you will apply, can you obtain TR quickly here? What will be your T of R? T of R, how to obtain T of R? That is L minus 1 integration of 0 to R to R, but here the variable of the integral is W, so 2W divided by L minus 1 square, and this is dW. Okay, so can you give me, so this is what this is R is given to me and I obtain T of R, that is my first step is completed. Uh, just a second, I have taken it. Okay, um, okay, so I have obtained it. So my first step is completed here, that I have taken T of R. So can you quickly tell me that what will be T of R? Take this one and give me the final answer. Then I have Z. I will obtain G of Z. How to obtain G of Z? Again the same methodology. What is that function? So G of Z for it is L minus 1 integral of 0 to, again the W variable, you can instead of W, you can, if you want to take any variable, let me check what they have taken, T. They have taken T, so that any variable, any W variable of integral you can take. It should not be Z, otherwise it will, you will get confused here. This will be Z, this will be Z from 0 to Z, and integral variable I am taking T. So this will be 3T square divided by L minus 1 cube, right? So cube and dt. That is okay. Instead of W, I have taken W variable as T, and this is what I have obtained. Equalization, I am giving the name instead of TR, I can give that function name as GZ, so that I can, whenever I take inverse, I should not get confused with this equalization function and this equalization function. That's it. That's why different names are given. They are just variables. So just give me the value of gz and tr, then we can move forward. So many examples to cover, right? So quickly do that, otherwise we will need some extra time to complete. So better we complete it in this ongoing session. Quickly, tr and gz. So what is your tr? What is your answer for tr? Yes, it is r square divided by l minus 1. Tr is r square divided by l minus 1. Okay, and gz is 3z square. 3z square, right? It is 3z square divided by, is it 2? Okay, here there is a conflict between Hena and Rahul. What it will be? I mean, give me one answer out of this two. Mistake is there. Okay, so should I assume it is z cube divided by l minus 1 square, or it is something else? Check for gz, all of you. Give me the final answer. Z cube divided by l minus square, till time I am assuming it is so. Verify and let me know if it is not correct. Okay, so assuming that it is right, okay, okay, fine. So you found your mistake, right, Rahul? Okay, so now we are having these two terms. Now we are having these two terms, these two terms are ready with us. Now I want to equate these two and I want to obtain z in terms of r. That's it. That is only the thing remaining. So now equate these two and obtain. So if I will equate these two, so what I'm going to get? Suppose I'm equating these two. So what I will obtain here is um, r square divided by l minus 1 is equal to z cube divided by l minus 1 square. Right, now what is my requirement? My requirement is that z in some form of r, some form of r, some function of r. So what I have to do? I have to take inverse of this. That means if I want to remove this cube, I have to take 1 by n cube root. I have to take this l minus 1 square is divided, so I have to multiply. So that is what inverse is, right? So in short, obtain l minus 1 square. So how will you obtain that? Ln minus 1 square will go here, cube root will be taken. Simplify, what it will be? So l minus 1 square will go over this side. So instead of this will get cancelled out with this, and over here l minus 1 will be there, right? And this will have cube root. So this will be our cube root, right? So this is what, but okay, so that is what we are obtaining here, that this is what we have obtained. Z is equal to this. Okay, so what is the point? Like, take your intensity, take your input intensity, multiply, square it, then multiply it with L minus 1, take its cube root, whatever answer comes, that will be your Z. In that way, you repeat for all the R values, you will get all Z values. Now, whatever image is ready, that image will have your specified histogram. Okay, so that is what the meaning is. Okay, now are you clear with all of you are clear with this process of continuous one? Simple process that take is equalization of both the images, right? And the equate them and take inverse function. Now we are going for discrete version, right? This is for the discrete version. So you remember, this equalization process will change to, instead of integration, it will change to summation, nothing else. Okay. So I'm not repeating that procedure. Let us start with directly example. This example we have already calculated. Equalization. So what I have, this is my input image available to me. This is the input image available to me. This is my input image R available to me. This is input image Z. This is Z is available to us. What is not available here? What is not available is, suppose these three are available or not. If these two lines are not available, these columns are not available. Can you obtain this column from these two available columns? How will you obtain this third column from these two available columns? So how will you obtain the third column? Third column is nothing but probability of, yes, it will be nk divided by 4096, because 4096 is total number of pixels. That is true. Okay, now what we are having here is, now what we are having, so this is okay, this you can easily obtain, and equalization of this we already have completed, and we have obtained that 0 should be replaced with 1, 1 should be replaced with 3, and that we have already obtained. So equalization of this is available to us. It's the same, in the same way, if you will equalize what is available here, they have not given nk to us for second image. They have directly given us that p of z, that is normalized histogram, directly is given. So no issues. So already this step from obtaining, from this to obtain this step is already given to us. Now, so already what we have, we already have t of r. How we obtain? From the previous example we have obtained the same. Now we want to obtain g of z. But how to obtain g of z? So for that what we need, so I want to get g of z for value, well, for z is equal to 0. I am writing it as z0. For this value I want to get, right? So how to get that equalization? So I know that L minus 1 summation of pz from 0 to 0, that is 0 itself. So that is L minus 1, in my case is 7. L is 8, so L minus 1 is 7. So 7 into 0. So result is 0. So, so what is the meaning? Gz, if I write here Gz, or if I write it equalized function, so that will be, for Gz of 0 is 0. So now what you are going to do, quickly do this task and let me know the other values, and you also know that what you can say, round it off as well. What will be for this? So how to obtain for 1? G1. So this will be from 0 to 1. Pz, that summation of these two. What will be the result? Result will be 0, right? Here also the result will be 0. Here the result will be 0.15 into 7, and 0.15 into 7 will be 1.05, and if you will round it off it will become 1. So it is 1. So this is 1. In that way this will become summation of all this, that is summation of this 2 at least, into L minus 1, and whatever the value will come, it will be 2.45 rounded off to 2, then 5, 6, 7, then it is 5, 6, 7. So this is how histogram equalization took place, right? So now I have TR. What is TR? TR is also known to me. What is the TR? 13566 Now, what is my requirement? If in my input R occurs, I should replace with which Z value? That is what my question is. What should be my Z value for the corresponding value of R? So, how to take inverse here? So, I will take, if my input value is 0, right? Here actually now I should have mapping here. Like I should equate two. What should I equate? I should equate this column and this column. But it is very difficult to equate this in direct way. So we have a methodology. Logically, it will be equating of this two. But how will we start? We'll start with, if in my input R0 occurs, what will be its equivalent TR? It will be 1. That TR maps with which GZ? That maps with this GZ. And what is corresponding Z value of that GZ? That is 3. That means if my input 0 occurs, it should be replaced with 3. Again I repeat for this, if in my input 1 occurs, what will be equalized value? It will be 3. That equalized value should be equated somewhere here, but here there is no direct mapping here with 3. So you can take the nearest value here. What is the nearest value of 3? Nearest value of 3 is 2, and that 2 value, 2 and 5, but 2 is even more nearer. So that 2 value, what is correspond? So equation is done. Like 3 is equated with 2 because it is the nearest value. So equal part is done. Now inverse part is remaining. That what is the inverse value of that value? That is 4. So whenever 1 occurs, it should be replaced with 4. Okay, now again we can start with 2, that if in my input 2 occurs, equated value is 5, that should be equalized value is 5, that should be equated here with 5, inverse is to be taken, and corresponding value of Z is also 5, and hence this should be 5. So 2 in my input should be replaced with 5, right? Same way for 3 and 4, it is 6. 6 is equated with 6, and inverse is also 6. So this 3, 4 should be equated to, this should be replaced with 6. 5, 6, 7 are having value 7, are equated with the 7, inverse is taken, and that is what is 7 here. So now in my input, all zeros should be replaced with 3, all ones should be replaced with 4, all twos should be replaced with 5, and in that way image is created, and that will have histogram as per my desire. So can you give me what will be, how many pixels will have value 3 in my output now? How many pixels uh, in my output will have value 3 now? Yes, they are 790 pixels. Yes, they are 790 pixels are having value 3 now. Okay, so what will be its, so okay, how many pixels will have value 0 to 1, 0 to 2? Now my out, if input is 0, it should be replaced with 3, and in this way it should be replaced. So now in my new image, how many pixels will have value 0 to 2? Yes, 0 pixels will have. Okay, so what is the probability of occurrence of 0 to 2? Probability of occurrence of 0 to 2 is also 0. Probability of occurrence of 0 is also 0 to, I mean, it is 0. So that is what we wanted and that is what we obtained, right? Probability of occurrence of 0 to 2 should be 0 and that is what we obtained. Okay. Now 3, for 3, the 790 pixels are there. So what is the probability of occurrence of 3 in my image? So 790 divided by total number of pixels, so that will be 0.19 and that is what we have obtained, 0.19. What was desire? Desire was to obtain 0.15. We obtained 0.19, so it is nearer. Of course, it will not be exactly same because we are using discrete versions, right? Same way, if you will check for 4, it is 0.25. 1023 pixels are having value 4 and 0.25 desired was 0.20, but again it is nearer. In that way, you can check for 6. The probability of occurrence of 6 will be these two pixels, summation of these two, and if you will go for that two values, of course it will be summation of these two probabilities, and that is this one, sorry, this one. Okay, so you can see that whatever we have obtained, actually obtained, what was specified and what we actually obtained is nearer, and that is how we are obtaining histogram specification. Now only the question, that is what we have already discussed, that this was the desired one, this is what we obtained, but of course it is quite nearer and this is what we had. From what we had to what we obtained is nearer to this. This is what the transformation that we applied. Okay, so this is all about histogram matching. Okay. Now the question is that how will we come to know that to enhance our image which type of histogram we should specify, and that is totally uh, that totally based on trial and error and your logic and your practice. We don't have any specific rule on which kind of image we should use to specify the histogram. You should have some intuition, based on that you can have trial and error, that's it. Any doubt in this histogram matching process? Okay, now we are going to the next case, that is local histogram processing. What we will do here, we will take our image, right? We will take our pixel, we will select a pixels, one pixel, then we will select its neighborhood. That neighborhood can be of size 3 cross 3, 5 cross 5, any. Then we will apply histogram equalization as if the image is like this much only. We will apply histogram equalization here and we will obtain entire table. What will be the table? That if my input image is having value 0, what should be my new value? What should be in my new value? That was 1, if you remember. Then this is 1, then it was 3. Kind of thing you will obtain for this portion, assuming that your image is just 3 cross 3 or 5 cross 5. In that way you will obtain a table. Then you will take center value. Suppose that center value is 5, and you will see in that table what is the value, what is the equivalent value of this 5 after histogram equalization. And that 5 that value 5 is replaced with this equalized value. Okay, then you will go to the next pixel. Okay, you will go to the next pixel here, which is its neighbor. You will select its neighborhood. Definitely its neighborhood will be like this. Suppose it is 3 cross 3, so its neighborhood will be like this, right? Again you will assume that image is like this only, this much size only, 3 cross 3 or 5 cross 5. Again you will apply histogram equalization process to this. Locally histogram equalization process is applied. You will obtain a table. You will select the value here. What is the center value? Suppose it is 3. You will see in that table, because now table will be different because your image is different, right? So in the new table, you will see what is the equivalent value for 3, and that 3 is replaced with that particular value s that you have obtained in this new image, new table, new methodology. I mean, new uh, table for equalized image. And that process you will repeat for all this local neighborhoods, or that local histogram processing is applied to all the possible neighborhoods. Neighborhood size you are going to keep fixed, right? Once you will decide it is 3 cross 3 or 5 cross 5, that will be kept fixed for entire image, and using that neighborhood you will almost scan, or you will scan your entire image, right? And you will apply histogram equalization to that, center value is replaced with that. Now you may, so what is the advantage of doing so? Advantage of doing so is, suppose you are having this type of image, and if you are applying histogram equalization to entire image, entire portion, then it might not enhance the image with, enhance the results which are hidden in the dark portion. Here you can see something is there. If you, we can visualize, it is some information is there, but it is not enhanced properly using histogram equalization over entire image. So that what you did it in the local neighborhood, you consider this as image only and enhance it. So if you are enhancing this entire image, or you are considering this as image and you are enhancing it, definitely this is going to give you better results, right? So because here see histogram, here why it did not work, because here bright intensity and dark intensities both were present. So what histogram equalization is doing, that it is giving you the stretch to dark to bright, but already both the intensities were present, that's why it did not work in this particular region. But in case if I am taking only this much portion, it is just having dark intensities. So if I will apply histogram equalization, stretching will be much better, because all the dark intensities are now mapped to dark to bright. Here already dark and bright both intensities were that, so stretching will not be that much impactful, right? So in that way, if it was done, then we have obtained this type of information which was hidden in these blocks. So local histogram processing, what is the process? Take pixel, select its neighborhood, apply histogram equalization to that neighborhood, obtain a table, replace center value from that table. Okay, but some of you might say that it is very complicated, lengthy, computationally heavy process, because that you have to histogram equalization you have to perform for every pixel, right? I agree, it is a that is a computationally heavy process. So that what can be done, that is alternative method. What is that? That is, if you are selecting your pixel, suppose you are selecting a pixel and its neighborhood, so it will look like, suppose I am selecting this pixel, right? And if I am selecting its neighborhood, suppose this is its neighborhood, then apply histogram equalization over this neighborhood, change all the values of this neighborhood instead of just center value, change all this value from this table obtained, right? And now you shift somewhere here, take non-overlapping neighborhoods, take non-overlapping neighborhoods, and again apply histogram equalization here, right? Apply histogram equalization here, and replace all these 9 values if it is 3 cross 3 neighborhood using that table that you obtained. Then again go to a block which is non-overlapping to this. So at least number of required operations of histogram equalization can be reduced. But because this process is totally different, these values are obtained from totally different table, then this totally different table. So what can happen? You might see such blocky effects. Some blocks, certain blocks are enhanced heavily, certain blocks are enhanced lightly. In that way, blocky effect you might see in that type of images. But that is a disadvantage. But advantage of that is that undesirable blocky effects are obtained. That is a disadvantage. Advantage is that computations are less. So this is all about local histogram processing. Any doubt up to this? Okay, now we are going for the next case, that is image statistics. What is image statistics? Finding mean and variance, right? So what is mean? How to find mean? For that, suppose I have a simple example to find out mean. So what I can do is that I have to just sum this up, divide by total number of observations. Summing all and divide by total number of observations will give me the mean. Alternately, I can write it as 1 into 4, 3 into 2, 4 into 1, 5 into 2, 6 into 1. I can write this summation as this: 1 occurs 4 times, 3 occurs twice, 4 occurs once, 5 occurs twice, and 6 occurs once. In that way, I can obtain this. Divide by 10. 10 is total number of observations, right? So in that, if I divide this 10 individually here, I might obtain this type of equation. And if you will observe this, what is 4 by 10 for 1 in this given data set? What is probability of occurrence of 1 here? Out of 10 readings, 1 occurs 4 times. So what is the probability of occurrence of 1 in this set? Yes, it is going to be 4 by 10. So what I can say here, that observation into probability of occurrence of that observation plus again observation, probability of occurrence of that observation. So what we can obtain is that or observation and probability of occurrence of that observation and summation over all possible observations. What are the possible observations? 1, 3, 4, 5, 6. So for summation of this term over all possible observation will give me mean, right? So now this statistics we need to apply over image. I have image. Suppose my image is having value 3 cross 3. This assume this is my 3 cross 3 image, right? And it has certain values. It has certain observations. It has certain assume it is 4 cross 4. Whatever it, I mean, it has n cross n image. Let us take that n cross, be more specific, m cross n image, right? So I have certain image. Then what? How can I obtain the mean of this? Simply mean is that suppose I am denoting my image as f of xy, where xy is the coordinate of this arbitrary pixel. Xy is the coordinate of arbitrary pixel, right? So how to obtain mean? So mean is nothing but that summation of all pixel values, right? Summation of all pixel values where where x will vary for what is the range of x. So x, if it is indicating number of rows, then number of rows in my image are m. So x is indicating is from 1 to m. Or if I am going from 0, if I am giving the number, then if I am giving index value from 0, then it is 0 to m minus 1. Y is from 0 to n minus 1, and such all xy, or rather if I'm taking 1 to m, 1 to n, that is okay. If I'm taking summation of all such arbitrary pixels, divide by m into n will give me the summation, or give me the mean of my image, right? Or alternatively, what is alternate method? That observation into probability of occurrence of observation. That means what I want to sum this all things, right? So I will take this value, probability of occurrence of this value. What is that? That is R, and probability of occurrence of intensity PR, right? And summation over all possible values of R. Possible values of R is 0 to L minus 1. My intensities can take place from 0 to L minus 1, and that is how we can obtain the mean. So that are two methodologies that I have to find out P, right? It is M cross N image, so that is how. So if you are going from the sample values, then it is also known as sample mean. We are going for the probability values, it will be 0 to L minus 1. Okay. What about variance? So variance is obtained, it is nothing but okay. So possible value of your um, possible value of um, your observation minus mean square, right? And into its probability. So that is what the definition of variance is, that observation minus mean, observation value minus mean square, right? So this is what the equation of your variance that you have. So how we can do that here, that I will take, if I am using the early first methodology, then I will take my observation over all the observations minus mean value that I have obtained and square of it, or I can take possible intensity values minus m square of that and probability of occurrence of that possibility, that probability of occurrence of that intensity. This is how variance is defined. Okay. Now, last question to you. Okay, this is for nth moment. Variance is second moment. If you want to go for nth moment, the square should be replaced with n. The square should be replaced with n. Because you know that variance is second moment, nth moment is defined as n here. Now, question is that what mean and what variance indicates. So, can you? Okay, so what is the variance? Variance is that if this is my probability of occurrence of if this PR is my probability of occurrence of particular observation, and this it is looking like this. This is my one PR, and another PR is looking that probability of for image 2, that PR is like this. Can you tell me, this is for image 2 and this is for image 1, can you tell me image 1 or image 2 has higher variance? Image probability of occurrence of intensities is distributed in image 1 like this, image 2 like this. Can you tell me image 1 or 2 has higher variance? Yes, image 2 has higher variance. What does that indicate? Okay, can you tell me which image 1 or 2 has higher contrast? 1 or 2 has higher contrast? Yes, 2 has higher contrast, because this is what probability of occurrence of intensity, nothing but, it is nothing but your, what you can say, it is your um, histogram itself, right? So if contrast is higher, I mean if variance is higher, contrast is higher. So actually variance is measurement of your contrast in the image. And of course variance is what, that from how different, how it will vary from your mean value, how it is deviated from your mean value, right? So if it is deviation is more, that means more values are included, that means contrast must be higher. So variance of the image is indicator of contrast in the image. And what about what mean indicates? Suppose I say that mean of one image is 10, that is intensity, mean intensity of one image is 10, another image is 100. Image 1 has mean value 10, another image 2 has mean value 100. Image 1 or 2 is a brighter one. Mean of one image is 10, another image is 100. 1 or 2 is a brighter one. Again 2 is a brighter one. Why? Because average value is nearby 100. That means compared to 1, 2 must be brighter. So what mean indicates that how average intensity is distributed, right? So if you want to check, this example is given to you, that if you want to find out mean, simple thing that you can do is 0 plus 0 plus 1 plus 1 plus 2. In that way you can go for all the readings and you can divide it by 25. That is one methodology, right? And another methodology to find mean is you can find out probability of occurrence of 0, probability of occurrence of 1, 2 and 3. What are the possible values? 0, 1, 2, 3 that we have obtained, and then you can go for summation of those values like RPRI. That is, what is the probability that 0 will take place? What is the probability that 1 will take place? In that way, you can obtain summation of this RPRI and you can obtain the mean. Of course, both means are going to be same. So this is all about statistics of image. Any doubts so far in image statistics? Okay, so we are concluding the lecture here.